Good evening, ladies and gentlemen. I present myself for anyone who doesn't know me. My name is Mabrouki Noura. I'm here today to talk about characterization of some crystalline phases of Algeria's rocks between brackets Ouargla region. I have divided my talk into introduction, then experimental study, after that results and discussion, finally conclusion. Let's now look at introduction. The rocks are found everywhere on the globe, deserts, mountains, beaches. We also find rocks for many and varied uses, including building, decorating building, facade making, columns. We also note the huge quantities available of the Earth's crust, quartz, and other minerals represented in sand, sedimentary rocks, and other were the greatest inspiration and encouragement to study these minerals in many international research centers and universities. Our work relates to the study of the molecular structure in order to know the minerals it contains and the possibility of their use and the benefit from it, the future as a precursor for the development of piezoelectric materials. Let's now move on experimental study. This sample was brought from the south of Algeria as shown in figure 1. This sample is distinguished by remarkable hardness, homogeneity of brown color as shown in figure 2. After we got the sample, we put it inside the grading device as shown in figure 3 to obtain a sample in the form of flour, and this we can perform analysis on it. I'd like to move on results and discussion. Here are explained the different steps involved from the collection and preparation of sample to the equipment we used for sample identification and a set of physico-chemical spectroscopy methods used for structural analysis and quantitative. The first analysis is analysis results by SAM. The spectrum in figure 5 and table 1 of the mass and atomic ratio of this sample list the results obtained by the analysis of the sample uses the scanning electron microscopy. These results show that the sample is composed of the following chemical elements: silicon and oxide with significant atomic percentage and a minority of composition in elements L and Phi that we can consider them as impurities. The second analysis is analysis results by X-ray diffraction. After viewing the sample on an X-ray diffraction apparatus, we get the spectrum shown in figure 6. Through the X-ray diffraction curve, the sample for which the analysis was performed was described using the BERT high-score program, where the experimental spectrum was compared with the spectrum contained in the databases and the match occurred with the calcium, iron, and silicon oxide. From the databases, this program also allowed us to determine the crystal structure of this sample, which is orthorhombic. I'd like to finish by saying, during this study, we afforded to contribute to the valuation of rocks as they cover vast areas on Earth and are considered a natural material that contains many raw materials. Through this work, we studied the composition molecular of a sample and known the ratio of each component thereof. This is by using the scanning electron microscopy and X-ray diffraction. The main objective was to search for minerals in the sample, where we obtained the existing minerals and the ratio of each mineral, and found the proportion of quartz that occupies the first rank among the ratio of other minerals, and the anorthic crystal. Through these results reached, we were able to conclude the type of rock, which is a sedimentary rock, and the field of research remains open in this context, especially with regard to the disclosure of the nature of the links that we couldn't identify and how to exploit what was disclosed in new technological application. Thank you for good listening and following up.